Srinath?
Okay.
Wait, Miss.
Um,
Okay.
okay, never mind.
Wow. Good morning, teacher.
Morning, Cha.
Morning, sir. We are a bit worried. Why is there no teacher suddenly?
What were you?
Ayus.
Okay, how are y'all?
Okay.
Okay, teacher. Why is Nick so confused today?
No. I don't know.
Okay, all of y'all are here. Okay.
Good morning, Miss Shaina.
Morning. Can y'all hear me clearly?
Yes, Cha.
Gotcha.
I just wanted to annoy you before the class started.
Annoy me?
Heck, no need.
Okay. How are y'all? How was your weekend? How's your week so far?
We had a weekend.
Okay.
Oh yeah, yeah. It was fine.
Okay. That's good.
So how was yours?
Mine okay. Was okay. Yeah. Okay. Yeah, we'll start soon. So we're doing this paper. So I uploaded this paper online and we will go through the answers. Okay?
Okay, sure.
Okay, Cha.
I've seen a graph last week.
What?
I remember that graph from last week.
Oh, cool. Congratulations.
Oh, did we do this last week?
Yeah, I remember doing this last week.
That means you all did all of this already.
I think so.
I remember the graph. The graph I saw last week.
Yeah, I still remember this graph.
Yes, we do already.
We discussed it already. Did we?
That's already.
Gotcha.
Yeah,
Ah, yeah,
we do
sure.
already.
Yeah,
So,
Cha,
yeah,
this
we
one.
discussed already.
This one also?
Yeah, sure. This one also.
I don't know.
Yeah, this one specifically. Then
Yeah.
heat we did already.
Okay, give me a moment, just hang on. Just okay, wait, let me just put it up on the screen first so I can show you to do. Okay, can you all see it on my screen?
Yes, sir.
teacher.
So do number 1.
Okay.
Oh, but you all won't be able to measure the. Okay, never mind, measure from the. Okay, never mind, can measure. Number 1, number 2. Do number 1 and 2 first.
Teacher.
Okay, Cha.
It's a
In terms of measuring, because you all don't have like paper to measure it on, you just measure based on the PDF that is given to you lah. Or if not, you can you can measure it on the computer since we don't have a paper.
Okay, teacher.
For those of you all who are using looking at the screen, at my screen and doing, let me know when you want me to scroll down.
Okay.
All right.
Teacher can scroll down. Teacher
Yes.
can scroll down. Okay, thank you, teacher.
What?
Teacher can scroll down.
Mingyan and Beatrice, okay?
Teacher can scroll down. down. You can scroll down. Here, and scroll down.
Teacher, is it okay if I don't know a question how to do it?
Which one is it?
It was, wait, where is it? It's question 2B. I'm kind of confused with that.
2B.
Yeah.
Okay, let me look at it on my phone. The column heading, is that the one?
Yes, teacher.
So you have to write what is the unit for T and the other one.
Yeah.
Yeah, so that's what it's asking you to do. You have to complete the heading.
Oh, okay, teacher.
You can scroll down. Please.
Should I keep scrolling?
Yes, teacher. Okay. Okay. You can scroll down. You can scroll down. Yes.
Sorry, did someone say something?
No teacher, no teacher.
Scroll down.
Yes, yes. Okay.
Sorry, you want me to scroll?
No, teacher.
Actually, no, that's the last part of it. This is the last part of question 2. Then we'll discuss.
Teacher.
Teacher.
Okay, can I see a show of hands of those who are still doing 1 and 2? Who need some time to finish? Okay, I'll give you another 5 minutes and then we'll discuss.
Teacher.
Okay, let's discuss. I'm going to go back to the top. Okay. So we have the class determining the weight of a meter ruler using a balancing method. Okay. So a student places a load P at the 90 cm mark on a meter ruler and then balances the ruler on a pivot. Okay. Measure the distance X from the 90 cm mark to the pivot. What did you all get?
2.5 cm.
0.
Mine is 2 cm.
I got 1.4.
Okay. It's going to vary lah because we don't have it on paper, but that's okay. Okay, how about Y?
I got 2.6.
2.6.
3.4.
Okay.
0.5.
Okay, any other answers?
2.6.
It will vary.
2.
2, okay. Calculate the actual distance X from the 90 cm mark to the pivot.
I got 88.6.
Figure 1 is drawn 1/10. So what do you do?
You times it.
Sorry?
1 over 10 times 90.
No, this is 1/10 of the actual size.
So, is it 90 minus 1.4?
Why 1.4?
I don't know, man.
Okay,
Where 1.4 came from?
1.4 divided by
I don't know,
10.
bro.
what did you get for X?
I never do, I don't know.
I didn't know how to do this.
Oh, for the small X, what did you all get for the small X?
1.6.
Oh, 1.1.
1.4.
1 point. Okay, the question says that this figure is drawn 1/10 of the actual size. Okay, I'm going to
So,
switch to my whiteboard. Oh, okay, so 1/10 of the actual size. One-tenth of the actual size, which is big X, is equals to the small x. Correct?
Yes.
Yes, teacher.
Okay, so 1/10 of the big X will give me the small x. So I want to find what big X is. So big X, what is small x?
1.4
1.4.
1.4.
times
X will be 1.4 times 10. So whatever small x you get, you just have to times 10 to get the big X.
Oh,
So it's 14.
Teacher.
It's 1.4, then the actual will be 14. No? The big X will be 14. You times 10. Okay?
Okay.
Y.
Teacher.
I think Y also they ask the same question, right? So you times whatever small y you get, you times 10.
So it's going to be 2.4 times.
2.5 times 10, which is 25, I think. Ah, yeah, 25.
yes.
Okay. So next, determine a value W1 for the weight of the meter ruler using the equation, that equation, where P is 2 and P is the weight of the load. So you take P, which is 2, you take your big X, you multiply it, and then you divide it by big Y, and then you should get your answer. Okay, so just plug it into the formula. What do you all get?
1.077.
Okay, what else? Any other answers? Anyone?
1.6.
1.6? 1.6, ah?
Yeah.
You took 2 times?
1.6 over 2.
No.
Oh, is it a big X or small x?
X, so you must take 2 times 16.
Okay.
This is big X. Look at the formula, it's big X. Anyone else? Any other answers?
Yes, next book.
Wingyan, what did you get for your answer? B3?
Sure, I never do this question.
Do you know
200.
how to do? I cannot hear you. Can you speak louder?
No.
No. Okay. So did you get your big X and your big Y? Yes, no?
No.
Okay. Did you get your small X and your small Y?
No.
No? You know how to get small X and small Y or not?
Yeah, just now I know, but
Sorry?
honestly.
Okay, so you get your big X, you times 10, you take your small X, you measure, you times 10, you will get your big X. Y also same thing. Small Y you measure, that is your small Y, and then you times 10, you get your big Y. And then you plug it into this formula. Okay?
Okay.
Okay, next. The student keeps the pivot at the same position, moves the load P to 95 cm mark. He places a load Q of weight 1 on the meter ruler. He adjusts its position so that the ruler balances. So on the figure, mark with letter Z the appropriate position of the load. You do not need to carry out a detailed calculation. So roughly, where do you think Z will be at? Q. Where will load Q be at, roughly?
50 cm mark.
Sorry?
So would it be at like the 50 cm mark?
50 cm?
Yes.
As in like here?
Yes.
Okay, anyone got any other answers?
No, sir.
So it's somewhere here lah, between the pivot, between here and the, let's say this is the center of the ruler. Let's say this is the center of the ruler. So it should be between this place and this place lah, around here. Okay?
Okay.
All okay so far?
Yes.
Okay. Next. The student expects W1 and W2 to be the same. So W1 is here. Okay. Do you get the same? Do you get the same W1? Does W1 and W2 are the same? Are they the same from what you got just now?
No.
Teacher, I got for the W1, I got 1.17.
Okay.
I got 200.
200.
Yes.
What is your big X?
X. P is 2. X is 16.
Okay.
Okay. Okay, teacher. My wrong. I put 25. My mistake.
Okay, so you should get around the same around here. Again, our measurements will be a bit off because of us measuring on the screen. But yeah, you should get around the same lah. Okay.
Teacher, 1.17 is wrong then?
It's not wrong. I think there is a bit of inaccuracy because we are measuring from the laptop and from the phone. So on paper
Okay.
it's different. But you should get around the same if you do it on paper lah. So that would be the statement. The statement would be, yes, W1 and W2 are the same. Or if let's say when you do another question, if it's not the same, you say they are not the same. And then your justification is based on the results lah. You can say that when calculated, we get the same value with W2. That's your justification lah. Justification is based on the results. Okay, anytime you justify a statement when you do paper 6, it's based on the results. Okay, so you just state that, okay, when calculated, you get a similar value or approximately the same value. Okay, suggest one practical reason why it is difficult to obtain exact results with this experiment. Why is it difficult to get exact results?
The pivot is not in the middle of the meter rule.
Okay, the pivot is not in the middle, so what does that cause?
The what do you call that thing? There will be more load on one side than the other.
Okay, so what will that cause? What will
It won't be balanced.
Okay, yeah. So you can say difficulty in achieving balance. That's why it is difficult to obtain exact results. Okay. So it'll be difficult to achieve balance. And then sometimes even with this, right, let's say you put the load. You see, you mark from the center. You take the measurement from the center of the load. Sometimes when you have a load, you might not take it from exactly the center. That's also another reason why it could be inaccurate.
Okay, sure.
Okay. That's one practical reason. You can just give one lah.
I haven't read it.
Okay, let's look at the next one. What is the initial temperature?
$85.
85.
You put
85
What is your column heading for time?
Second.
Second.
seconds.
Temperature?
Celsius.
Degree Celsius.
Hey, sorry, degree.
Plot the graph of
Oh, sorry.
temperature against time. Okay, can you all send me your graphs? Message on the, yeah, send me now. I want to see.
Okay, Joe.
Take a photo and then send it. Okay, Nicholas one is okay. But you will, Nicholas, you need to put label your axis,
Alright.
and put a title, please.
Okay.
Okay. Sherlock also okay, but same thing, please put a title and label your axis.
Okay, sure.
Okay, the rest, please send.
Teacher, mine is sending, it's very slow.
Okay. Okay, the rest of you quickly, yeah, I'm waiting.
I can't send picture.
Huh?
I can't send picture.
Oh, you cannot send, okay, yours you send after class, lah. Okay, next one. Mehak, your time needs to be at x-axis, Mehak.
Oh no.
The left-hand side of the column is always on the x-axis. In the table, the left-hand column is always on the x-axis. What you're measuring is the one that needs to be on the y-axis. In this case, they are measuring and recording temperature. So what is recorded is what that is always on the y-axis.
Okay, sure.
Lohendra, yours?
Actually, your son again.
Okay.
Teacher,
Yes?
there's something wrong, but I currently sent the photo. It's just not loading.
Oh, okay. Okay. Then later you try again, lah. Okay.
Okay.
Lohendra, yours is okay, but you don't use a ruler to draw. You have to make a smooth curve.
Teacher, sorry.
If the readings are uniform, okay, but this is not. And please put a title as well.
Okay.
And on the left-hand side, your y-axis, right? Your y-axis
Ah,
has to be uniform. You cannot just put the values of the temperature like that. You have to put like 10, 20, 30, 40, 50, 60, 70 like that. You cannot just put the readings like this.
teacher.
Okay, Wingyan, yours is okay, but your graph, it starts from 40, 50, 60. You have to start from, if you're going to do 10 intervals, 40, 50, 60, you have to start from 10, 20, 30, 40.
Okay.
But the rest is okay.
Okay.
Okay, so that is that. Mehak, you're still loading up. Oh no, Mehak, I already give feedback. Okay.
Yeah, so I'm almost done with it. I'll send you another picture.
Okay, yeah. Please correct those who are doing correction, please correct it and send it to me now.
Okay, teacher.
So I must send it to you where?
Okay.
Where I send to you? How do I send?
Send your book to post laju to teacher's house.
Joe.
On that photo can ah? If on the phone cannot, then at Modo lah.
WhatsApp you cannot.
Can.
Teacher, what's your number?
Oh, okay. Let me message you. Shaluk, yours is okay. Just that for the time,
Till the time I miss a 10 lah.
yeah, you have to put seconds and degrees Celsius.
Yeah, I can't send now. I send later only.
Can. Mehak, yours is okay. Just put the unit for time and temperature on your axis.
Okay, sure.
Okay, let's go on to the next one. State whether the rate of cooling of water in the beaker increases, decreases, or stays approximately constant during the period of cooling. So the rate at which it is cooling, is it around the same, or is it decreasing, or is it increasing?
Decreasing.
Decreasing.
Okay, it's decreasing from 85 to 72 to 64, 60. It's not decreasing uniformly because it's not dropping like every 2 degrees Celsius, or it's like 60, 55, 50, 45. It's not uniform like that, but it is decreasing. So the rate of cooling of the water decreases. Justify your statement by reference to the graph. So basically, again, like I said just now, justify means you look at your results, and now it says by reference to the graph. So what can you say?
The temperature is reducing at
Study rate.
Is it at a
yes.
steady rate though?
No.
It is not
No,
85.
it's not.
No, then what you say?
If it's steady rate, then the graph will look like this. It will be a linear graph like this. Wait, let me show you. Like that. Then the gradient is constant, so it's decreasing steadily. But now our graph is something like this.
It is decreasing at an unsteady rate.
Yeah, so you can say that it's decreasing not steadily, or you can say not. Okay. Or not linearly. You can also say that. All okay?
Yes.
Yes, teacher.
Okay, Wing Yan, yours is okay except for the axis. Oh yeah, in fact, the axis for all of y'all, you don't write X or Y for your axis. You write time and temperature.
Huh?
And then you put your unit there. Okay, you don't have to put X or Y, X and Y. Because now your X-axis is now time, so you put it as time. Okay.
If you put X and Y, it's wrong.
Yeah, you have to label your axis.
No, if you label and put X, it's wrong.
If you label, put X, okay lah. But that's not the right way of doing a graph though. Yeah. Okay? Okay, I will give you all a break. Come back at 10:07 lah. 10:07, 10:10 lah. Come back at 10:10, and then we will do a few more questions.
Okay.
Okay, ciao.
Okay, thank you, teacher.
Teacher.
Okay, everyone back?
Yes.
Yes, no. Okay, this is the next paper. Oh, hang on. Let me send it to the WhatsApp group again. Okay, can you all see the paper?
Yes.
Yes, sure.
Number 1 and number 3. 2 no need, 1 and 3. Okay, let's start with number 1. And then you need to scroll, let me know.
Okay, sure.
You can scroll down. Teacher. Can scroll up to the experiment now. Up. The picture of the experiment. Okay. Okay, teacher, can scroll down.
Let me scroll down.
Okay. Okay. Thanks, teacher.
Done? Are you still here, or can I scroll to the next one?
Can scroll to the next one, teacher. So that's all about Samu.
Sorry?
That's Samu.
This question 1, that's all.
Okay.
Shall I scroll to question 3?
Can, teacher.
Miss Sharina,
Yes?
teacher, how do I put the numbers of like, for example, 0.05, how do I put them uniformly in the graph?
So if you're going to start with 0.05, and then you can do 0.05. Are you starting with 0.05?
Not sure. I haven't calculated that yet.
Oh, okay. Then you just have to make sure that, let's say it's 0.05, and then you go to 0.1, and then 0.15, 0.2, 0.25, 0.3. It has to be uniform. Or if let's say in this case you have what is the reading for this one?
1.5. Yeah. No, wait. 0.
What 115?
Yeah, sorry, bro.
You can start with 0.5, 1.0, 1.5, 2, or you can start with 0.25, 0.50, 0.75, and then 1, 1.25, 1.5. It doesn't matter what numberings here, as long as they are uniform in terms of all these values.
Okay, teacher. Thank you.
Okay.
Yeah, I don't know how to do this.
Which one?
The 2I1 Roman letter 2.
This one. This question?
Yes, teacher.
The students repeat the procedure for all the values. Explain how the student could make sure that the ruler is horizontal before each reading. How to make sure that the ruler is is horizontal when, what's the question? Before each reading. So how to make sure that this ruler will be like this? So one thing is they could put something underneath here. So you can put something underneath the ruler that is also horizontal, so that this ruler will be horizontal. Sorry?
Something.
I can't hear you, girl. Can you speak louder?
Balance it, but with something.
Something else which is horizontal as well at the bottom.
Teacher
Yes?
can scroll to the table. Okay, thank you, teacher. Teacher can scroll down. Okay.
Okay, this is the last part to the question, yeah? Can I see a show of hands of those who are done with the whole thing? With question 1 and 3? Okay. Mahendra, okay ah?
So wait a bit more, sir.
Nicholas, Shaluk, okay?
Yes, sir.
Yeah, sure.
Okay, sir, done.
Okay. We will discuss in about 5 minutes or so.
Okay, sure.
Okay, let's start discussing.
Teacher.
Okay. Okay, let's look at the first one. Complete all the headings. What would the unit for time be?
Seconds.
Temperature.
Degrees Celsius.
Degrees Celsius. Okay.
And what will be the time here?
It'll be 30, 60, 90.
It starts from
0.
Eh? Oh, 0, sorry.
30, 60, 90, right up to 180. Okay, describe 3 precautions which should be taken to ensure that the temperature readings are as accurate as possible.
The same amount of water
The same temperature.
and same temperature and amount.
What precaution should be taken so that the temperature readings are accurate? So that means when you read the temperature, you are reading it like it's accurate temperature.
Oh.
What were your answers?
You're not looking from the top, you're looking at the eye level.
Okay, look at eye level. What else? What was your answer just now? Mohindra, what was your answer?
Temperature.
Huh?
No, okay.
Now, what do you do? What precaution do you take so that when your temperature readings are accurate? You want to keep it as accurate. So one is when you read the temperature, you must make sure that you're reading it correctly, like eye level. What else?
Make sure the thermometer is not touching the beaker.
Yeah, you must make sure that the thermometer is not touching the beaker. It is in the water, not touching the sides of the beaker. What else?
Pour the same amount of water in each beaker.
That's what I said just now.
That would be under here.
Yeah.
That would be under 2. In terms of temperature, other things that you can do is make sure when you're reading temperature, right? Now these answers is universal answer. When you have other questions that are related to thermometer reading, you can also use the same answers. Another thing would be read until the reading stops rising. Then only you mark the temperature. While it's rising, you shouldn't mark the temperature. Okay? So one, make sure you read it at eye level. Make sure the thermometer is not touching the beaker. Wait until the reading stops rising at start. Okay? Now, write a conclusion stating how the use of the lid affects the rate of cooling of water. Justify your answers, giving reference to the results. With the lid, what happens to the rate of cooling of water?
Will be
More quickly or more slowly?
slowly.
Slowly.
So you can say the rate of cooling is slower. Now justify your answer. Justify again, you use the results.
The water won't go out very easily.
Sorry?
And nothing, teacher.
Use your results. Look at the reading. What is happening to the reading?
It's decreasing.
Decreasing, but is it decreasing quickly or slowly?
Slowly.
Slowly. So justify your answers by reference to results. You say, based on the table, the drop of the temperature is very slow. For each 30-second interval, the drop of temperature is very little, very slow. So the first thing you say is the rate of cooling is slow. Justify your answer. You say for every 30-second interval, the temperature drop is slow.
Okay.
Okay, suggest one change to the apparatus or procedure to make the comparison a fairer test. Explain why the change makes the test fair.
Same volume of water.
Okay, so here you can put same volume of water. Why, and then what would your explanation be? How will same volume of water make it a fair test?
So the both will be doing the same job. And
If it's there more water means then the
Yeah, then it
temperature
should be
might
a
be
higher
different a bit.
temperature.
Correct.
Okay.
Yeah. So when you want to do an experiment, you want to make sure that there's not many factors that are changing. Here, the factor that is changing is one is lit, one is without lit. So make that the only changing factor. The difference, the rest all you try to keep it the same in order to make it a fair test. What else must be same?
The size of the beaker.
Okay, so the size of the beaker, because that will also, yeah, correct. Some more?
temperature,
Sorry?
temperature,
What temperature?
The starting temperature.
Yeah,
your
starting temperature. Oh, Tachu, what temperature were you referring to?
the starting temperature.
The initial temperature you start as the same. Okay. You can also put insulation at the side of the beaker, put rules and all, so that the cooling is not affected by the outside temperature. Also can. So it's only affected by whether there's a lid or not. That's another thing. Okay. Any suitable answer lah. Okay, the temperature of the water in each beaker decreases. Describe one other similarity in the pattern of cooling in beakers A and B. So both are decreasing, but what is one other similarity in the pattern of cooling?
Going down 10.
Going down at the same
They're
time.
going down by 1.
1.
No, they're not. Okay, it's different. I'm not functioning.
3, 4, 5, 6, 7. Then don't have 8.
Similarity between both in terms of pattern. Of course, beaker B is cooling down less rapidly, but there is a similarity in the pattern. What is it?
It's decreasing. Both is decreasing unsteadily.
Sorry?
Both is decreasing uniformly. I don't know
Yes.
if that's a word.
Heck, you copying Nicholas, right? Hey, you.
Okay, what else?
Sorry, Nick.
It's going down by 10.
No.
Huh? 10?
What? 80, 70, 60.
Oh my
Both
god.
also both decrease the temperature very fast. I don't know.
Okay, so both
At the beginning, they decrease fast. Then after that, they decrease by 1 degree.
correct. So you can say another similar pattern is, although beaker B, the rate of cooling is slower, but for both beakers at the start, at least the first 60 to 90 seconds, it is a rapid cooling. Only after that, this beaker A is faster. Beaker B is a bit slower. But you can see at the start, both are cooling more rapidly. Okay. Okay, record the room temperature shown. What is the temperature shown?
23 degrees Celsius. 23.
3 degrees Celsius. Make sure you have your unit. Another student is carrying out the same experiment in a room with a room temperature that is much higher than 23. Okay, so the room temperature is now higher than 23. Will this affect the cooling of the water in beaker A?
Yes.
Yes.
Yes. Why?
Because the atmospheric temperature might.
Atmospheric surrounding.
Yes, I just said, my heck. It's the same.
I didn't hear. Oops, my bad.
How will it affect the cooling of the water?
The temperature from the atmosphere might combine with the temperature in the beaker.
So what will that cause? So what will happen to the cooling of the water?
It will cool down slower.
It won't be accurate.
So
It
will
won't
cool
be
down
like
slower,
different.
rate of cooling. Because the difference between the water and the room temperature will now be smaller because they are almost the same. If it's similar, if it's almost the same as the room temperature, so the rate of cooling of the water will be lower.
Okay.
What's the answer again?
The rate of cooling of the water is lower.
Chalundra.
Huh?
Nothing. Hello, Lohindra.
Okay, it's actually
Hello lah vợ đi.
we'll
Orang noisy.
look at
Sai what?
Sure.
since it's 11 o'clock already.
Chưa,
Chưa chưa.
chưa.
Yes.
Hello.
Okay,
Look.
okay, that is all for today's class. I will see you all next week, okay?
Bye,
Okay.
Joe.
Teacher.
Teacher. Thank you,
Bye.
teacher.
Thank you, Joe.
Yeah.
Thank you, Joe.